1.5, function arithmetic. If we have two functions, f and g, and x is in both domains, x is in both domains, we can write the following. F plus g, it's a new function called sum, and it's defined as f of x plus g of x. So if we add two functions, we create a new function called sum. If we subtract the two given functions, f of x minus g of x, that's called the difference. If we multiply them, then this new function is called product. If we divide them, we need to add here the denominator should not equal to 0. That new function is called quotient. So example, if f of x is 6x squared minus 2x, it's quadratic. G of x is 3 minus 1 over x. Find a f plus g, the sum, at -1. So it's specific input, -1. So by definition, f plus g at -1 is f of -1 plus g of -1. So f of -1 would be 6 times -1 squared, or you can do it separately, minus 2 times -1 plus g of -1 will be 3 minus 1 over -1. And you calculate this, and after you simplify it, you should get 12. So in that new function, if the input is -1, the output is 12. B, we want to find the product, f times g, at 2. By definition, that's f of 2 times g of 2. And if you want to do this separately, I'll do it separately here. F of 2 is 6 times 2 squared minus 2 times 2. 24 minus 4, that's 20. And g of 2 is 3 minus 1/2, which is 2.5. So back here, we had 20 times 2.5, which is 50. So the product is 50. So C, find the domain of g minus f and simplify. So we're going to find g minus f. By definition, that's g of x minus f of x. And g of x is 3 minus 1 over x minus f of x is 6x squared. Since we're subtracting, that will be plus 2x. So to simplify means to have the same denominator. So we're going to have everything with denominator x. I'm going to have 3x over x multiplied by x top and bottom. This one I'll copy the way it is. Here I'm going to multiply by x, divide by x. And here multiply by x, divide by x. So that's equal to 3x minus 1 minus 6x squared plus 2x all over x. So now we have to write the domain of this new function. So the domain will be all real numbers except 0, because we don't want the denominator to be 0. Another definition here for difference quotient. Given the function f, the difference quotient is f of x plus h, minus f of x over h. So you can calculate this difference quotient for different functions. Let's do that. One example here. We use this in calculus, the difference quotient. So find and simplify the difference quotient of f. Find and simplify the difference quotient for f of x equals x squared minus x minus 2. So it's a polynomial function. We'll do it several steps. The first step will be to find f of x plus h. I'm looking at a formula here for difference quotient. So f of x plus h is x plus h squared minus x plus h minus 2. Here we're going to FOIL x squared plus 2xh plus h squared, distribute. Okay, x squared. Is there any like terms? No, that's it. Okay, so we'll leave this like that. And the second step would be, here's our first step. The second step is f of x plus h minus f of x. That's the difference. And then we're going to do the quotient. So we have x squared plus 2xh plus h squared minus x minus h minus 2. And we're subtracting f of x, which is x squared minus x minus 2. So I'm distributing here, and I'll look what can cancel. So I see x squared with a negative x squared, x with negative x, and 2 with negative 2. What's left? 2xh plus h squared minus h. That's it. So the third step, we'll write the quotient. Looking back at our formula, we have f of x plus h minus f of x all over h. So what we got in step 2, I'll write it on top. And now I can factor out h from the numerator, 2x plus h minus 1 divided by h. We cancel h. When you find difference quotient, you're always going to cancel h. And this is what is left. 2x plus h minus 1. And that concludes the lecture for 1.5.